Hey guys, so for today we are going to be looking at the final subtopic or the final part of chapter 2 chemistry, which is atomic structure. So for today we are going to be learning on electronic configuration. Okay, electronic configuration. Basically about drawings and all those stuff, arrangements and stuff that you guys need to know properly according to a couple of rules in order to make sure the electronic configurations of elements are correct. Okay, electronic configuration basically means describing the distribution of electrons in orbitals in an atom. So there's two ways to write. Okay, number one is in orbital diagram, and number two is in SPDF notation. Okay, so what does orbital diagram and SPDF notation actually means? Okay, let's have a look over here, just a simple one. Okay, let's try an element, lithium. Okay, let's take lithium, Li, and Z is the proton number, which is equals to 3. Proton number is equals to the number of electrons if the atom is stable. Okay, please note that. Okay, now orbital diagram literally means 1, 2, 1s, 2s. So there's 3, right? 3 electrons. So 1, 2, 3. Okay. SPDF notation literally means 1s2, 1s2 electrons, 2s1, 2s1 electron. Okay, don't worry, we'll be learning about it further. Okay, now before we move on, I'd like to explain a couple of rules whenever you guys need to assign electrons. Okay, let's have a look. Okay, the first one is called Aufbau principle. Aufbau principle. It's AUFBAU, Aufbau principle. Okay, what does Aufbau principle states? It states that electrons are arranged in the atomic orbitals in order of increasing energy. Okay, the lowest energy levels will be filled first. Okay, let me repeat it. Electrons are arranged in the atomic orbitals in order of increasing energy. The lowest energy levels will be filled first. Okay, so basically, Aufbau principle means you have to follow this arrangement. Okay, 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6p, 6d, 6d, 6f, and finally 7s, 7p, 7d, 7f. Okay, so you guys have to follow this form. Let me do it in red. 1s, and then you gotta go 2s, 2p, 3s, 3p, and so on. Okay, now let's have a look. How do we actually use it? Okay, let's have a try with calcium. Okay, let's have a try with calcium. You guys know very well for s orbitals there's 1, for p orbital there's 1, 2, 3, and for d orbital there's 1, 2, 3, 4, 5. You guys want to know what is 1, 2, 3, 4, 5, 1, 2, 3, and 1? The previous session we have learned N, L, M, S, and so on. Try to find out which is the one exactly describing 1, 3, and 5. Okay, so now let's try something simple. Let's try fluorine. Fluorine, Z equals to 9. Z over here means proton number. But remember, when an element is in a stable condition, proton number is equivalent to electron numbers. Therefore, 9 will be the number of electrons too. So over here, it will be 9 electrons, right? So 1s2, 2s2, 2, 4 already. So 2p, what is the remaining? 5. Okay. Why 2p5 is accepted? Because Aufbau principle states, I'm sorry, why 2p5 is accepted? Because p is equal to 3, right? So 1, 2, 3. Each orbit, you guys know very well, can fill in 2 electrons. So it'll be 1, 2, 3, 4, 5. Okay, that is how we draw it. Let's say we have 5 over here. 1, 2, 3, 4, 5, and then 6, 7, 8, 9, 10. You don't draw it 1, 2, and then 3, 4. No, you don't draw it like that. You draw it all the spins first. Remember the spins that we learned previously? Positive 1 over 2 spins and then negative 1 over 2 spins. That is how you're supposed to draw it. Okay, so for p orbital, maximum is 6 electrons because p has 3. 3 times 2 equals to 6 electrons. So it can still allocate 5 electrons. But remember, it always has to be increasing in energy due to Aufbau's principle. So you'll go 1s2, 2s2, 2p6, 3s2, 3p6, 3d, 10. Exactly. And then we move forward and forward. All right. So that is the first principle. Now, let's have a look at the second one. The second one that we are going to learn over here is Pauli's exclusion principle. Pauli's exclusion principle. Okay, Pauli apostrophe S, exclusion, Exclusion principle. Okay, so what does Pauli's exclusion principle states? No two electrons share the same quantum numbers. Okay, what do they mean by quantum numbers over here? We have learned in the previous session, quantum numbers, NLMS, and so on. Okay, and then it also states electrons with same spin cannot occupy the same orbital. Okay, the maximum number of electrons in one orbital is 2. Like just now we have seen 1, 2. Okay, maximum is 2. Okay, let me show you one by one. So the first one, they literally mean NLMS. Okay, you can't have two, let's say 3110 and so on. 3112, let's say 3112. You can't be having the exact same number for another element. Okay, no two electrons share the same quantum number. Sorry, 311 positive 102, because the last one will be your spin. Okay, so no two electrons share the same quantum number. Basically, you have to make sure NLMS, the same number is only for one electron. No two electrons share the same quantum numbers. Okay, that's number one. Number two, electrons with the same spin cannot occupy the same orbital, which literally means just now we learned. Tadi dah belajar kan S, P. Let's say this one. 1, 2, 3, 4, 5, 6. Ni betul, ni betul, ni betul. Ni salah. Kenapa? You cannot be putting the same spin. This is positive 1 over 2, this is positive 1 over 2. Whenever it's down, it's negative 1 over 2. So you have to draw upside down. Okay? Always opposite. Because Pauli's exclusion principle states that electrons with the same spin cannot occupy the same orbital. That's the second one. The third one, the maximum number of electrons in one orbital is 2. I think it's quite obvious over here because over here, sini ada satu elektron, sini ada satu elektron. Just spin yang berbeza. Okay? Alright, now let's have a go and try with an example. Let's say we are talking about helium over here. Z equals to 2. Okay? Proton number is 2. So the SPDF notation for helium is 1s2. So your orbital diagram will be like this. Please don't forget to label 1s. Alright? That is how it's going to work. Make sure your 1 is bigger than your s. Okay? That is how the standard method. Okay? That is for Pauli's exclusion principle. Now, the last rule that we are going to learn for today is the Hund's rule. Okay. Let's have a look what does the Hund's rule states. HUND' rule. Okay, what does it state? When electrons are placed in a set of orbitals with equal energies, the electrons must occupy them singly. Singly bermaksud satu persatu. Okay, with parallel spins before they occupy the orbitals in pair. In pairs. Okay, let me read it out again. Hund's rule states that when electrons are placed in a set of orbitals with equal energies, the electrons must occupy them singly with parallel spins before they occupy the orbitals in pair. Okay, what do they actually mean over here is, kan tadi kita dah belajar 1s, let's say, okay, 2s, then 1, 2, 3, 2p. Okay, what do they mean over here is, okay, ini 1, 2, 1, 2. You have to draw singly first on a parallel spin. Parallel spin means this positive 102, this positive 102, this positive 12. Lepas tu, kalau dia lebih daripada 3 elektron, let's say dia 4 elektron, baru you buat negative 102. 5 electrons, baru negative 102. 6 electrons, baru negative 102. Make sure it occupies like this first, and then you draw the opposite spin. Make sure it's in different orbitals because each orbital can only occupy a maximum of 2 electrons. Okay? Alright, now let's try carbon. Let's try carbon. Carbon, the Z atau proton number is equal to 6. So the SPDF notation will be 1s2. Okay, 2 electrons sudah ada. So balance 4. 2s2 because S orbital can only occupy 2 electrons because 1 je sini L dia. For P ada 3, for D ada 5. Okay. 1s2, 2s2, 2p, 2. So 2, 4, 6. 6 electrons. Now, let's draw them. 1s, 2s, 2p. So it'll be 1, 2, 1, 2, 1, 2. That is how you're supposed to draw it. Okay? Alright. Okay. So, we have done all the cases for 3 different rules. Okay. But there's an additional part over here. Let me explain 2 different types of things. Okay. Number 1, let's say your 1s, 2s, 2p, 3s, 3p, 3d. Okay. 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2. Okay. Now, let's have a look at this kind of situation. Alright, just now we have learned this thing, right? All this arrangement according to the energy. Alright, there's something called the anomalous case. The anomalous case. You spell it N-A-N-O-M-A-L-O-U-S. Anomalous case. It literally means different from what is expected. Okay. Case number 1. Dia ada 2 je anomalous case that we are learning. Number 1 is chromium. Okay. Chromium, dia punya electrons atau proton is 24. SPDF notation dia adalah 1s2, 2s2, 2p6, 3s2, 3p6, 4d4, 4s2. Ini adalah SPDF notation yang biasa. Tapi due to the fact chromium is an anomalous case, so what do? This is how it deviates atau berbeza daripada yang lain. So you have to draw the orbital diagram. Let's draw one by one. 1s, 2s, 2p, 3s, 3p, 3d, 4s. Okay, so what you need to do is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Now do you see 3D5, 4S1? Tadi when we did is 4D4, 4S2. Okay, kenapa dia macam ni? Okay, the anomalous is due to the electron arrangements want to achieve stability of half-filled orbital arrangement. Stability of half-filled orbital arrangement. Tengok sini. 3D5. This is half-filled orbital arrangement. That's why the 3D5 is such. Dia bawa masuk macam ni. Okay? It's not this electron gonna go here. No. This is called half-filled stability orbital arrangement. Okay? Since the 4s and 3D energies are very close, okay, the energies are very close. How do you know? Because kat sini kita dah bincang 3D and 4s are very close. Sebab lepas 3D adalah 4s kan? Okay, since the 4s and 3D energies are very close, one of the electron from 4s2 orbital, sepatutnya 2 kan, is able to jump to fill the partially filled orbital of 3D4. Sebab initially we did, it was 3D4, okay? Sorry, it should be 3D4, okay? Kalau you arrange ni betul-betul, dia akan jadi 3D4. But because of they want to achieve the stability, this electron over here is passed through over here, okay? To produce 3D5 and 4S1. Okay, let me just repeat this again and make it clear. The anomalous is due to the electron arrangement wants to achieve the stability of half-filled orbital arrangement. Since the 4s and 3D energies are very close, one of the electrons from 4s2, initially it's 4s2, okay, orbital is able to jump to fill the partially filled orbital of 3D4, initially it's 3D4, sebab dia partially filled and it's able to jump, that's why it becomes 3D5 and 4S1. That is the anomalous case number 1. Alright, let's have a look at anomalous case number 2. Anomalous case number 2 would be for copper, Cu, with proton number of 29. Okay, the actual electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2. Okay, sorry, 4s1, my bad. Will be 4s1. Okay, now let's draw the orbital diagram first. 1s2, 2s2, 2p6. Make sure you guys notice my drawing up first and then down. 3s, 3p, 3p6, and then 3d. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 4s1. Okay. The anomalous. Okay, you guys can see over here, right? The anomalous, kalau you guys buat satu persatu mengikut yang kita dah belajar previously, yang ini, dia punya SPDF notation akan menjadi lain. Tapi because this is anomalous cases due to certain reasons, that's why dia punya SPDF notation adalah berlainan. Okay, so the reason behind it is the anomalous is due to the electron arrangement wants to achieve the stability of full field orbital arrangement. Can you see over here? Full field orbital arrangement. Since the 4s and 3d energies are very close, one of the electrons from 4s2, initially it was 4s2, lepas tu dia donate kan, is able to jump to fill the partially filled orbital of 3d9, initially it's 3d9. Tapi for S2, the second electron is able to jump to 3D9 to make sure it is 3D10 and the 4s jadi 4s1. So those are the two anomalous cases that we will be touching on our syllabus. Okay, guys? I hope you guys understand about electronic configuration, the principles that you guys need to follow, the rules and the techniques of answering questions, and also both the anomalous cases and the SPDF and orbital diagram. Okay, guys? I hope you guys enjoyed this session. Have a great day.